Hello and welcome. Today we are going to be working on Chapter 1, Section 3, looking at exponents, roots, and order of operations. We have a few different objectives to look at today. We want to be able to use exponents, find square roots, use the order of operations, and evaluate algebraic expressions for given values of the variable. Starting off here, again looking at how we use exponents. So a to the nth power, that's we write that because we have n factors of a. We call n the exponent, a is the base, the whole a to the nth is an exponential expression. Exponents can also be referred to as powers. So looking at the bottom here, we've got a few different examples. So 4 times 4 times 4. There's 3 4s, so that would be 4 to the third power. For something like 3 to the 5th times 3 to the 5th, it's 3 to the 5th squared. Now these parentheses are important. They show that the entire 3/5 is getting squared. For the next example, C, again we can see that we've got 4 negative 6's, so that ends up being negative 6 to the 4th power. And again, those parentheses are important. They show that the negative is also repeated 4 times. Down at the bottom, next example, we've got 0.3 to the 5th power. So that again shows that the 0.3 is repeated 5 times. Parentheses there are not actually necessary, but it's okay to have them. And if we have a variable like an x, 6 times x to the 6th power. Here we'll take a look at evaluating exponential expressions. So just kind of mostly just reminders. So something like 5 squared, every once in a while someone will make the mistake of treating that like 5 times 2, but it's really 5 times 5, and so we get 25 for 5 squared. When we have a fraction like 2/3 to the 3rd power, again that's really 2/3 times 2/3 times 2/3. Another way to think of that is we have 2 to the 3rd power over 3 to the 3rd power. Either way we get 8 over 27. And then a 2 to the 6th power, pretty straightforward. It's just 6 2's multiplied together. We get 64. And you can type those into the calculator. At this point, we kind of want you to be thinking about this. And if you were to type this second one into the calculator, you have to be really careful about how you do that, because you can type that in the wrong way and get the wrong answer if you don't use parentheses on that. Looking at these, evaluating exponential expressions with negative signs. So very important here that we are careful with how we do that. Again, you could type this into the calculator. What I'd rather kind of see you do though is realizing that something like negative 3 to the 5th is going to be negative because there's an odd number of negatives there. And then you could always type in 3 to the 5th to the calculator and get that that's 243, so then you'd know that has to be negative 243. Compare that to the negative 2 to the 6th, and there the negative is also repeated, but it's repeated 6 times, so since that is even, then the negatives would all cancel out and we would just end up with a 64. And then the third one there, then just plain negative 2 to the 6th without any parentheses. Again, showing that in that case, then the negative is not repeated 6 times. There's only the one negative. So you multiply the 2's together, you get 64. You still have that one negative out front. And then at the bottom, just a little summary there that the product of an odd number of negative factors is negative, and the product of an even number of negative factors is positive. Taking a look at finding some square roots, and we're going to be kind of just doing this in terms of knowing how to square things. So the first one, the square root of 36. Well, we know 6 squared is 36, so the square root of 36 is just a plain 6. The square root of 0 is 0. Sometimes people get confused by that, but again, remember 0 squared, of course, is 0. Square rooting a fraction like 9/16, really we can, the way I think of this is square rooting the 9 and getting 3, square rooting the 16 and getting 4. You could also think of 3/4 squaring that and you'd get 9/16. Square rooting something like 0.16 the way that I like to think of that one is to really convert that to something more like the 9/16. So we can think of that square root of 0.16, that's 16/100ths, and the square root of 16, of course, is 4, square root of 100 is 10. That does reduce down to 2/5, which of course is the same as 0.4. So, but to me, looking at that in terms of the fraction, much easier than the decimal. Looking at the next one, the square root of 100 is 10, and kind of a series here that we're going to build off of. And then if we have the negative in front of the square root, then we square root the 100, get 10, but the negative stays there, so negative 10. But if you try to square root a negative 100, that is not a real number because the negative sign is inside the radical sign. And so just contrasting those three can kind of show you the difference with those negatives. Next we'll take a look at doing some work with order of operations. So we'll try these problems. They already have some highlighting on them, but the very first one handling something like 5 plus 2 times 3. So again, with order of operations, you multiply or divide before adding. So we'd multiply the 2 by the 3. We end up with 5 plus 6. Of course, then that's the only thing left to do. So we end up with 11 as our result there. For the next example, B, we do have dividing and multiplying there. When you have both, you do those in order from left to right. So we would do the 24 divided by 3 first. Just put it that way. And then that would end up giving you 8. Still be multiplied by the 2 and then add the 6. So then we are looking between multiplying and adding. So of course we multiply first. And then we add those together. We get 22 as the result. And then moving down to the next example, notice we have that absolute value symbol. So that works just like other grouping symbols like parentheses or brackets. So we do that first. So we would be looking at having the 10 divided by 5 plus the 2, and then the absolute value of negative 1, which would be, of course, a positive 1. So we've got division, addition, and multiplication. Since the division and multiplication are separated by an addition, we can actually do those just at the same time. We get 2 plus 2. Of course, that then turns out to be 4. Taking a look at the next one, again we've got our grouping symbols, the 2 plus the 8. And we really could square that 3 at the same time, but we'll just kind of keep that separate. So the 2 plus 8 turns out to be 10. Parentheses at that point aren't necessary, but just emphasizing where that came from. Next we would take care of our exponent. So we'd have 4 times 9 plus the 7 minus the 10. Multiplication would be next, so 36 plus 7 minus 10. And then addition and subtraction you can do from left to right when you have both. So we end up with 43 minus 10, so it turns out to be 33 for that one. And then for example C, again we've got our grouping symbols. And then inside the grouping symbols we've got division and subtraction, so we would do the division first there. Because of how this is set up, we could do the 1/2 times 4 at the same time, because that is separated from everything else by that addition. So I'm going to go ahead and do that now. 1/2 of 4 is 2. 2 minus 7 would be a negative 5. So now it's a little bit goofy because we got 2 plus a negative 5. If you wanted to, you could think of that as 2 minus 5. You get negative 3. If you want to think of it as adding a negative, you could think of that as well. So yeah, negative 3, what we end up with there. And then we've got this example at the bottom. So this is the first one where we've got the fraction bar. Again, for order of operations, you do the two sides of the fraction bar separately. So if I work on the top of that fraction bar, I would take care of the cubing first. Now, that negative is not repeated. However, we still end up with just the one negative anyway, so it's a negative 8. And I could just go ahead and finish off the top there. So 5 and then plus the negative 16. So really 5 minus the 16, so that will end up being negative 11. Then we can go through and handle the bottom. The radical is the same priority as exponents, so that will come first. So square root of 9 is 3. Minus the 9 times the 2. Again, because those multiplications are separated by a subtraction, we can do both of those at the same time. Oh, and this will be a problem. 18 minus 18, so that's 0. So since we can't divide by 0, we would state then that that is an undefined result. There's nothing that works for that. That brings us to our final objective, evaluating algebraic expressions for given values of the variables. So given an expression like a 6ab or any of those others there, we should be able to take or values for a, b, whatever it might be, plug those in and evaluate the expression. So we've got a few examples here. We're going to go with m is negative 4, n is 5, p is negative 6, and q is 25 for all three of these. They don't all involve all of them, but just for the ones that they do. So here, the m would be replaced with negative 4, the n replaced with 5, and we still follow order of operations then. But again, since those multiplications are separated by a subtraction, we can do both of those at the same time. And we end up with negative 20 minus 45. So we get negative 65 as our result. Same sort of process for the next example. We plug the negative 4 in for n, the 5 in for n, and the negative 6 in for p. So in the numerator we would have negative 4 plus 10. In the denominator we'd have negative 24. The numerator ends up being a positive 6, denominator negative 24. That does reduce down to negative 1/4, and it does not make a difference if that negative is on the top or on the bottom. Generally I prefer that negative to be in the numerator. And then our final example, we've got an m. So we replace the m with a negative 4. The n is replaced with a 5. And the q replaced with 25. There's a few things we can do right away here because of the separation of the different pieces. So we could take care of the negative 4 cubed first. Cubing that would still give us a negative, and when you cube 4 you get 64. We can square the 5 to get 25, and we can square the 25 to get 5. So it looks something like that. We can go ahead and do both multiplications, multiplying that 3 by the 64, and of course those two negatives will cancel out. And we get a positive 192, and then the minus 25 times 5, which would be minus 125, gives us a total of 67. Well, hopefully this helped, and thanks for watching.